everyone, welcome to today's tutorial. So in this tutorial we're going to be discussing differentiation using logarithmic rules. So in other words, we're going to be differentiating functions using logs. So when we talk about logs, we do not have to leave the line. So if we want, we can use line or log, because what you should understand is that line is just a special logarithm. So if I say log a, line a, if I say line a, this is just a special logarithm. This is just the same as log a base e. So line a is simply just a logarithm with a base e. This is what we are seeing here. This is what we call line a. So line is simply just a special logarithm. It's also a log. Okay, so let's quickly begin to solve this. Alright, so the first question is asking us to find dy dx of this function here. So before I can even start, if you have not yet subscribed to the channel, make sure that you do so by clicking on the subscription button. And if you have any questions, feel free to contact me on any of the lines on the screen. And if you need to join the group where I post these tutorial videos, make sure that you contact me on any of these lines on the screen, and then I add you to the group. Okay. Alright, so let's quickly begin. So the first question is y is equal to x, the square root of x squared plus 1. So the first one is y is equal to x root x squared plus 1. So when they say we use logarithmic differentiation, they do not just they are not just limiting you to use logs. You can also use log. You can also use line. So you can use line and log, you still get the same answer, because the same rules that applies when you are using line are the same rules that applies when you are using log. Alright, so let us quickly begin to differentiate. So we're going to introduce logs on both sides. So I'm going to have log y this side is equal to log, then I'll have x root x squared plus 1 in brackets, of course. So before we even begin to differentiate, let us first deal with this expression here. We simplify it, because we know that where there is multiplication in logs, it means that we are adding two log functions. Where there is division, it means that we are subtracting two log functions. So let us apply those rules. So on the left here we have log y is equal to, and then this other side we're going to have log x. Because we're multiplying there, we're going to say plus log square root of x squared plus 1. Then this side we still have log y. We've not yet started differentiating, we're just simplifying. So this is just log x. Then here we're going to have log, this part can also be written as x squared plus 1 raised to the power half. So according to the rules of logarithms, this half can drop down this side, so meaning we're going to have something like this: log y is equal to log x, then we say plus half log x squared plus 1. So don't make a mistake to multiply the log with everything in brackets. No, you don't have to do that. So let us now differentiate. Here now we can differentiate because it's now straightforward, it's now easy, because I've simplified the expression. Okay, so the first part this side, we're going to use implicit differentiation to differentiate this part. So how do you differentiate using implicit functions? You differentiate, when you differentiate y, the answer that you always get is dy dx. So you get dy dx after differentiating y, but we also have to divide this expression by the original function. Remember what we said when you are differentiating logs. If you have, let's say, y is equal to log, okay, let me start with ln. If you have y is equal to ln x, dy dx is found by differentiating this function. You get 1, and then divide by the original function, which is x. So same applies to y. When you differentiate y, you get dy dx. Then we divide everything by the original function, which is just the same as multiplying by 1 over y. Okay, so let us now say this is equal to, we differentiate this, we also do the same. So the same rules that apply to ln applies to logs as well. So we differentiate the function x, we get 1, then divide by the original function x there. Then here we have half there, which is a constant. Then we also do the same here. We differentiate the function, we're going to get 2x, then divided by the original function, which is x squared plus 1. So we can now just simplify this expression. So now how do we do the simplifying? So we're trying to find dy dx. So dy dx will therefore be equal to 1 over x plus, so this 2 and that 2 can cancel, so we're just going to remain with x on top, everything divided by x squared plus 1. But when you check on my left this side, I've not written 1 over y because I'm trying to cross multiply it with these other things this side, so meaning the y will come this side. But we know that y is just equal to x x times the root of x squared plus 1, so I'm going to replace it there to find dy dx. Hence dy dx becomes 1 over x plus x over x squared plus 1, and then from there we can write our y there, which is x root x squared plus 1. This is how you differentiate functions using logs. Okay, so let's quickly move on to the next one. So I'm sure this one is also easy. We can easily do this this function. Rather, we can easily work with this expression. Okay, let's do it. We see how we can solve it. Okay, so let's do it. So we have y is equal to that. So I have y is equal to the square root of x squared x plus 1 and then x plus 2. So when we square both sides, we're going to have y squared this side is equal to, then this side we're going to have x squared open brackets x plus 1 and then also x plus 2 there. So I've just squared this part so that I can also have, so I'm trying to simplify this expression as simple as possible. I'm trying to make it as simple as possible. So if I want, I can also multiply this x squared into the brackets there, so that I have y squared is equal to x to the power 3 plus x squared multiplying with x plus 2. So I can now use logs, can now introduce logs. So in the first equation I used log, so in this one I'm going to use ln. Yeah, but the same way I used log, that's the same way you use ln as well. The good part with using ln is that log, at least log has 3 letters, so you take time writing 3 letters than writing 2 letters. So I'm going to use ln. Yeah, so whether you use ln or you use log, the rules that apply are just the same because they are all logarithms. Okay, so I'll introduce ln. So if you want to use log, you can introduce log. Yeah, so I'll introduce ln this side, which will be y squared. Okay, then this will be equal to, I'll also introduce ln this side, so I have x to the power 3 plus x squared, then have x plus 2. So this side we can simplify it further, so we have ln y squared is equal to, we're going to have ln, since we're multiplying here, we're going to do this, since we're multiplying there, we're going to have ln x to the power 3 plus x squared. Then what this multiplication means that we're adding, so plus ln x plus 2. So we can now differentiate. So this side, we differentiate the function there. When we differentiate the function, we're getting 2y. So when you differentiate the function, we're getting 2y, and then dy dx. Then we divide everything by the original function, which is y squared. So this is equal to, and then this side we also differentiate this function there, which will give us 3x squared plus, and then this other part will give us 2x. Then divide by the original function, which is x to the power 3 plus x squared. Okay, then we have plus, we also differentiate the function there, which will just give us 1, and then everything divided by the original function, which is x plus 2. So we can simplify that expression. We know that 1y there and 1y will cancel there, so just remain with this side will just remain with 2 over y dy dx. Then on the other hand, we're going to remain with, we know that x can go into 3x squared and 2x and x cubed and also x squared. Hence, you cancel out the x's, meaning you're just going to remain with 3x plus 2, everything over x squared plus x. This is what you're going to remain with. Then and then this side will still have the same 1 over x plus 2. So when you cross multiply and then divide by 2 in order to make dy dx the subject, you're going to have dy dx is equal to 3x plus 2, everything over x squared plus x, then plus 1 over x plus 2. Then we do this, then we cross multiply by, so we're going to have y over 2 this side. I've just cross multiplied everything and then divide everything by 2, so that I just leave dy dx along this side. So but y is known to be this, so I don't have enough space this side, so while there is y here, you can just replace back this expression, because this is the value of y. Then that's your answer. Yeah, so you just replace back the value of y there. Okay, let's quickly move on to the next equation. Move on to this one. Okay, so we proceed. So I'm going to solve this one. I think I'll leave this one for you to solve. I'll also leave this one for you to solve. I think I'll also solve this one. Alright, so let's quickly begin. So I'll start with this one. So we have y is equal to x squared, and we have the root of 3x minus 2 over x plus 1 squared. So we quickly introduce log on both sides. So I'll be exchanging, I introduce ln, I introduce log, so that you get used to both. So in this one I'm going to introduce log. So we have log y is equal to log, open brackets, x squared root 3x minus 2 over x plus 1 squared. So before we begin to differentiate, let's distribute the log to everything. And as we are distributing, you're not just multiplying log times x squared. No, you have to consider the rules of logarithms. So while there's multiplication, you're going to be adding. Then while there's division, you're going to be subtracting. What this means is that we're going to have log y being equal to log x squared plus log 3x minus 2. So if there's need for you to simplify the expression before you introduce the logs, you always have to do that. It really helps when differentiating. So where there's multiplication, I've put the plus. Then since there's this division, I'm going to put a minus. I'm going to say minus log x plus 1 squared. So we now apply the rules of logarithms. So we are going to have log y this side, and we are going to say this is equal to, if you want you can differentiate them the way they are, but if you want you can simplify them further by saying these two can drop there, so we have 2 log x. Then this other part can also be simplified as log 3x minus 2 to the power half. Any function that has been square rooted can also be written as to the power half. Okay, so we say minus, these two can drop, we say minus 2 log, then we have x plus 1. So we have log y is equal to 2 log x. Then this half can also drop down, so that we have half log 3x minus 2. Then this other part will remain the way it is, 2 log x plus 1. So now we can differentiate. So when you differentiate this part, we're going to get dy dx. We're differentiating using the implicity, so meaning we say dy dx time, when you differentiate this part you get dy dx, then we divide by the original function, which is y. So this is just the same as multiplying dy dx with 1 over y, which is equal to, in case you are not understanding what is happening here, when I say dy dx divide by the original function, in this case is y, so instead divide by y, this is just the same as saying dy dx times, you change this, so this one is y over 1, so you flip this, 1 goes on top, so you're going to have 1 over y, like that. Yeah, you remember grade 12 mathematics. And then when you multiply that, it's just the same as having this expression there. So we differentiate this part by differentiating the function there, and then divide by the original function as well. So when you differentiate this function, we're going to get 1, then divided by the original function, which is x. And you say plus 1 over 2, and then differentiate this function there, you are getting 3, then divide by the original function, which is 3x minus 2. Then we also do the same there, we have 2, we differentiate the function there, this will give you 1, and then everything divided by the original function, x plus 1. Okay, so we can now simplify this further. So we leave dy dx along this side, so dy dx will therefore be equal to, this function becomes 2 times 1 there, you get 2, and then over x, then this one also be, so we say plus, so we're going to say plus 3 over 2 times 3, that will give us 6x, 2 times negative 2, negative 4, minus 2 over x plus 1. But of course we're cross multiplying, there's this y here, we cross multiply to come this side, meaning our dy dx is going to be 2 over x plus 3 over then minus 2 over x plus 1. Then we close the brackets. And then the value of y is simply just this expression here, because they said y is equal to this. So the value of y, we replace it back there, which is just going to be x squared root 3x minus 2, everything divided by x plus 1 squared. So this is how you differentiate using logarithmic differentiation. So I guess this one is also simple. You can do it and then try to do it and then send the solutions in case you want to prove whether you are wrong or correct. So if you have not yet subscribed to the channel, make sure that you do so. I don't know, something is just pushing me to solve this one. Anyway, let me just show you how to solve it, then we move on to the next one. Let me just show you how to solve this one. Okay, I think this space is enough. So you introduce the logs on both sides. If you want to, we can introduce ln. So we say log y is equal to, there you are going to have log, then you have x plus 1, and then you also have x minus 2. You're multiplying and then divided by x minus 1, x plus 2. So where there is multiplication, you are adding. Where there is division, you are going to be subtracting. So let me do this. Let me just erase everything. Okay, so let me just alright, so let us solve this one as well. So the question is y is equal to x plus 1, then we have x minus 2, then everything over x minus 1, then there's also x plus 2. So the way we solve this one is straightforward. We introduce log or ln on both sides. So we have ln y is equal to ln everything in brackets. We have x plus 1 and x minus 2. Then everything divided by, we have x minus 1, x plus 2. So this can further be simplified, this expression here. So we have ln y this side is equal to, so we're going to have ln this, which is x plus 1 times, okay, ln x plus 1, let me just do this, ln x plus 1 times x minus 2, then we say minus, because of this division line, minus ln x minus 1 times, I'll introduce another set of brackets there. Okay, ln x minus 1 times ln let me do this. Let me put green. Ln x minus 1 times ln x plus 2. Okay, so we can now simplify this further. We have ln y this side is equal to, then while there is multiplication we add, so we have ln x plus 1 plus ln x minus 2, so minus, open the brackets, and then we have ln x minus 1, while there is multiplication we add, we say plus ln x plus 2. So we simplify this further, we say ln y is equal to ln x plus 1 plus ln x minus 2, then negative times that ln, we have negative ln x minus 1, then negative times positive ln that, we also have minus ln x plus 2. Okay, excuse me. So from there we can now say, we can now differentiate. So the first part here will give us dy dx times 1 over y. So this is equal to, and this expression here, when you differentiate, you're going to get 1, then everything over x plus 1, and then we say plus, when you differentiate this one, when you differentiate the function there, you get 1 over x minus 2. When you say minus, differentiate this expression here, you also get 1, and then over the original function, which is x minus 1. Even this other one, we also have the same, differentiate there, get 1 over x plus 2. So after doing this, you can now cross multiply and then replace the value of y to find the final answer. So dy dx becomes 1 over x plus 1 plus 1 over x minus 2 minus 1 over x minus 1 minus 1 over x plus 2. Then we cross multiply, so meaning you put y this side. So you just have to replace the value of y there. You replace back that function for you to get the final solution for dy dx. Alright, so this is how you find derivatives using logarithmic differentiation. So my name is Harmtedy. If you have not yet subscribed to the channel, make sure that you do so, and if you want to be part of a group where I post these tutorial videos, make sure that you contact me on WhatsApp using any of these lines on the screen. Make sure that you don't forget to subscribe and also click the notification button. My name is Harmtedy. See you in the next tutorial video. Shalom, shalom.